Continuing now to chapter 2, we need to establish a whole bunch of things in these first few sections. Now the first two I've sort of merged together here. So what we want to talk about are scattergrams and then creating models from those scattergrams and then using those models to answer questions. And that's really two sections in the textbook, but I'm kind of pushing them together into one. Okay, so let's talk about it. So first thing I want to talk about is a scattergram. Now a scattergram, sometimes called a scatter plot, same thing. They are, well, it's a, it's a plot, like an x and a y axis and such, with a whole bunch of points put on there. So a whole bunch of ordered pairs. That's a scatter plot. That's it. There's no lines, there's nothing. It's just dots. For us, generally, those dots are going to have a context. They're going to be things like, height and weight and stuff like that. But they're going to have a relationship. Otherwise, there's no point for us to be dealing with them in algebra class. Okay, so let's think about, one other thing real quickly, is that if they look like there's a line that kind of comes close to all those points, then we say that they're approximately linearly related. Approximate because it's not exact, but there's basically a line that follows them. So your job is to look at these 6 graphs and figure out which ones of them are linearly related. Linearly related. All right, so let me do that. Looking down here. So you can see with A, yeah, they don't form an exact line, but they kind of come close, right? There's a line that's sort of kind of hidden by those points, right? That would come close to all those points. So this one is linearly related. All right, if you look at B, B is not linearly related because those are not forming a line, right? There's a big curve kind of in the middle. All right, C is also not linearly related. C is actually a very special one. We're going to learn about this one a lot more in chapter 6, but it's called a quadratic. It makes a parabola shape. Right? Now D, however, is linearly related. Now they don't form a line. Take a close look. They're not exactly a line, but they're close, right? So that's close to linearly related. So I guess I should say approximately. So approximately linearly related because it's not exact, right? We're not talking about, yeah, the dots all formed a perfect line. That's not what we're saying. We're saying, hey, none of these are perfect, but are any of them close? And the answer is A and D so far are close to a line. E isn't close to anything. E has no relationship, is what we call. So I guess I can say not linear related. But in statistics class, you learn that this is actually no relation at all. That basically somebody just tossed the points up there, right? So they don't mean anything. And then F is approximately linearly related. It's important to note that A and D are increasing, so they would have positive slope, and F is decreasing, so it would have negative slope. All right, now let's look at example 2. And there's a whole lot going on in here, so we really got to pull this apart because this same techniques that I'm going to be using right now is going to become very important to you. You're going to be using these techniques all the time for these kind of problems. And these kind of problems happen in every chapter of this book. Every chapter. No, I'm not kidding. On every test, the final, they're all over. All right, so P is the percentage of 12th graders who have ever used smokeless tobacco at T years since 1990. Smokeless tobacco is another word for chewing tobacco, right? You don't set fire to it. It makes no smoke. That's smokeless tobacco. All right, now it's at T years since 1990. It says a scattergram of the data has been drawn, but one of the points is missing. Find the point and place it on the graph. So there it is right there. There's a point missing. So let me insert a little shape. I think it's in the middle right there. Hold on. Oops, I want that to be filled. And I want it to be filled with that color, and I want it to have an outline that's that color. Hold on one second. There. It'll be someplace over here because it's, well, if you want, you need to figure out which one you're missing. And the one you're missing is this one, the 11 one. Now, what am I getting the 11 from? So you'll notice here that up in the top there's some instructions, and this is going to happen to you a lot. Whenever they give you years in this book, they generally don't want you to use the years. They want you to use t, meaning time. Okay, so what are the t values here? T values are, well, since this is years since 1990, then the first year would be year 2, right? Because if you take 1992, take away 1990, literally do the subtraction. 1992 minus 1990, because that's your starter year, right? I mean, in fact, I'm going to bold this. So notice that is your beginning year, right? Starter year equals 1990. So that would be t equals 0. Okay? So that's your starter year. Then when they say 1992, that's got to be 2. 1995, that's got to be 5. 8. 11, that's where I got the 11 from. 14, 17, 18. Right? Okay. So how did I know the 11 was the one that I needed? Well, because that x-axis down there, that's not the year. It's the year since 1990. As a matter of fact, that's what I need to do. I need to label next. So we put in the missing point. We also need to fill in all the appropriate labels. So let's insert some, shall we? So I'm going to insert a label right here for the x-axis, which we just talked about should be years since 1990, because that's what your x-axis is actually standing for. Oops. There we go. All right, then what else? You also need a label up at the top, and you need a y-axis label. Let me format the text box and get rid of the line. There we go. Okay, so then I also need a y-axis label. So I'm going to need that somewhere soon. So I'm going to have to put it over on the other side. So instead of years since 1990, I need to label this what this y value is, and this was percent, right? And of course, you probably should make it so that it tilts, so that it's reading, you know, down to up, but that's too much of a pain, honestly, with the text box thing which I'm using. Okay, then the last thing we need is a label for the whole thing, and this was percent of 12th graders who've used smokeless tobacco. Percent of 12th graders oops, 12th graders who've used smokeless tobacco. Smokeless tobacco. All set. Ooh, probably should have capitalized that stuff. It's a title, so. And then we're all good. So we've done, let's see, part A. We filled in the missing point. Great. And we noticed at that time that, you know, we had this whole 11 thing going on, right? Where the time isn't this middle column. We changed that into these numbers over here because it gave us a starter year. We filled in all the appropriate labels. Then we have a line on our graph. Does this line do a good job of coming close to or on the data points? So I drew that line with a computer, and as you can see, yeah, it does a pretty good job. It's not perfect. It's not like the line that you're going to have goes through every one of them, right? So yes comes close to all the points, but it's not perfect, nor would it be. Let me see here, but it's not perfect because, let me put it this way, because the line averages out all the points. So the line doesn't go through any two particular points. It's that it averages out all the different points. So it takes some highs and some lows, but that line kind of cuts through the middle. So some points are above it, some points are below it, and it averages out. Now the question becomes, is the data in this problem approximately linearly related? Explain. Well, yeah, I mean, the points are kind of forming a line. So yes, because the points are more or less forming a line. They follow the trend of a line, if you will. All right, all done with that. Now we need to move on to the next page and start answering some other questions. Let's see what we got. So we need to be able to create a scatter diagram. That's actually for the page following. And on this page as well, like how would I make that scatter plot with a calculator? So let me just show you that real quick. So you go to your calculator and you press Stat, Edit. And okay, we type in the numbers from the table. So I have to go get the numbers from the table. There they are. Okay, so I'm going to type 2, enter 5, enter 8, enter 11, enter 14, 17, 18, and so on. Again, this is in the Stat Edit area. Very important. Now, what's L2? L1 is list 1. So list 1 was this stuff right here. Right? Now, L2 is the percents. We don't care about the years because the years have been transformed into these t values. So what we want is the percents. So we go 32.4, 30.9, 26.2. Except I messed that up. There we go. 26.2, 19.7, 16.7. Oops, I did it again. 0.7. And 15.1. And 15.6. Okay, so you put L1 to be your time. Matter of fact, I'll put that in L1, and then L2 is your percents. Sorry. Okay, so that's your L1, that's your L2, and again, all this is under Stat, number 1, Edit. Right. All right, so now that you have them in there, you need to turn on your scatter plot. Now your scatter plot is there's a short way to do this and a long way to do this. Now the short way is to go to y equals, clear out any old equations you've got, and go up to plot 1 and press enter. Then it'll be dark, which means it's turned on. That plot 1 is a scatter plot, at least it should be. Let me go to second y equals and I can check that. There you can see. My plot 1 is a scatter plot, so you can tell by the picture. It's got L1 and L2, and it's going to make little boxes. And if you want to edit that, you could press number 1 or press enter. And you can see, hey, it's on. I'm making a scatter plot, right? And then it's L1 is my X, L2 is my Y, that's my mark. So most of the time you don't have to bother going in here to the stat plot. So second stat plot, this portion, you don't really need this very often. It's only if you ever play around with this then change it to something else and you want to change it back. For the most part, you're going to turn in scatter plots just by pressing y equals, going up, pressing enter, and turning it off, and going up, pressing enter, and turning it on. That's how you're going to do scatter plots 95% of the time. It's just that. Go up, press y equals, go up, press enter, turn it on. If it's dark, that means that the scatter plot is on. All right, then you want to make a normal window. So if you press graph, you're like, where are my points? It didn't graph any of them. Au contraire. It did graph them, they're just not on the screen. So what you need to do is you need to follow those instructions where it says press zoom 9. Zoom 9. Ooh, you probably want to see what zoom 9 is. Oh, there's all these zooms. We don't want any of this stuff. There it is. See, zoom 9? Oh, I went too far. Zoom 9 is zoom stat, right? Zoom stat, i.e. stat is where you typed the data in, right? Get it? Statistics. That's what those numbers are in that table. They're statistics. So zoom stat makes an automatic window that fits your scatter plot. Very handy to have and know about. All right, so that's how to make a scatter diagram. Stat, edit, put in your data, go to y equals, clear out any old stuff, and put in plot 1, make it dark, and then zoom 9. That's a scatter plot. All right, we're done with that, and I'm going to pause right there because we're running out of time, and I'll pick up with this model stuff next time.